So, you know, in today's class, we will start to discuss about switch, how a switch works, how switch forwards data using a particular MAC address, etc. Okay, but before that, I just want to give you a brief of where we usually see switches or where we usually do not see switches in around us. Okay, so this diagram that you see in front of you is a very is a typical connectivity of devices using switch. Okay, imagine that this is a uh, topology, or this is a network connectivity of a small shop, which, or let's say a jewelry shop. Okay, jewelry shop, and the jewelry shop has many cameras. These are imagine that these are not PCs; these are cameras. Okay, so these are different cameras, and this particular thing is the computer that prints bills. Okay, and obviously you can see there are three cameras. These three cameras are connected to a switch, and this switch is also connected to the billing system. Now we know that the camera we know that the camera records everything. The camera records everything, right? 24 bar 7, 24 bar 7. And also because it's a jewelry shop, okay, it needs a high quality recording, not just any, like, 720 pixel or 1080 pixel. 1080 pixel is fine, but sometimes it may need a 4K resolution recording as well. So they may be a high quality, high end cameras that record everything 24 bar 7. And if you just imagine, this particular video that I am recording is at a it is at a 4K resolution that I'm recording it. Not 4K, it's at a 2K resolution that I'm recording it. And once the recording is finished, 2 hours of data, or 2 hours of recording, the size of that recording is around 2 GB, something like that. Okay, so that's the amount of data for a 2 hours of recording. Imagine 24 bar 7, it needs to a camera. One camera is recording every single thing. And imagine the amount of data that it can have in 24 plus 7 days. Right. Obviously, all these camera, they cannot have something to be they obviously they will not have such a huge memory, or a huge storing, or a huge storage or SSD size that they can store all the recording. What they do is they will send this particular recording out of the internet to a something called as cloud. Okay, they may have a storage server in the cloud. Okay, when we say cloud, cloud is not the cloud that we usually see, right? So cloud is another a huge server which has a huge storing capacity. Okay, so it sends the data over there, and whenever this particular billing system or this security PC needs to access those recordings, it can get that. Now the thing is, we as consumers in, or we as customers in a jewelry shop, we can only see, what we only see are these cameras and the billing system. That's all we can see. We do not see anything further than that. Okay, but we should understand that these cameras are in turn connected to one of these switches, probably one, probably two, or more than that. If it's a big jewelry shop, it may have more than one switch, right? But eventually all those switches are then connected to a router, which helps them send the data to the internet, and also helps them get the data from the internet, right? This is a typical connectivity of devices using a switch, right? And if I have to go further towards in a big company, or a big company, or even in our house, right? So in our house, the typical connectivity that we may see is a Wi-Fi router over here, which we in networking term we call it as an access point. A Wi-Fi router which is connected to different laptops, devices. It can be a laptop, it can be a PC, it can be a smart TV, etc. So our devices are connected to the Wi-Fi router wirelessly, right? And then what happens is that this Wi-Fi router, as I said, visually or visibly, we can only see the networking devices up till here at our home, right? Then what usually happens is that this particular Wi-Fi adapter sends the data, or it is connected to a switch. The switch is then connected to a router. This switch is not just connected to your Wi-Fi router, it is also connected to other Wi-Fi routers who are using the same ISP services in your building or in your locality, right? So let's say this is another Wi-Fi router over here. This is third Wi-Fi router over here, right? And this is a fourth Wi-Fi router over here, right? So there are multiple Wi-Fi routers that are connected to this particular switch, and the switch is then connected to a router. Or if you imagine this as a this as an office, small office, very small office, one single floor where there are just 10 or 20 employees sitting. So you may also see such kind of connectivity. Few employees are using laptops, few employees are using a PC that is directly connected to a switch. So this is how usually a switch topology would look like. And if we increase the scale of this particular topology, and if we just go to a big building where there are multiple floors, and on a single floor there are 50, 60, or even probably 100 employees sitting. So how would it basically look like, right? So it basically would look like this, where there are multiple PCs that are directly connected to the switch, or there are multiple laptops or phone devices that are wirelessly connected to an access point or a Wi-Fi router, which in turn is connected to a switch. So this is, you can see in the diagram, this is the third floor, this is the second floor, this is the first floor. So on each floor, you can see there is one switch which connects. Okay, in real network, there may not be one switch, there may be multiple switches on a single floor. But as per this topology I'm explaining, you can see on each floor, there is one single switch that is connected, right? And all these switches are then connected to another single switch, which is taking the connectivity from this switches, right? Then this switch is connected to a router, which helps you go outside the network or talk to any other people in the same enterprise network as well. So this is how your switch connectivity basically looks like. All right. I see some question on the chat. Does it include CCNP security course? No. This course is of CCNP plus CCIE enterprise. I'm focusing only on the enterprise enterprise. Okay, which basically is your routing and switching. Okay, the term is different, right? So as I said, again, I'm repeating. I have mentioned my number on the chat box. Please send me a hi. I will. What I will do is I will send you the recording from yesterday's class, or you can go to my YouTube channel. Let me again open up my YouTube channel. You can go to my YouTube channel, click on the playlist. You will see CCNP plus CCI. Okay, you will see one video which is from yesterday demo session, where I've explained all the CCNA, CCNP, CCI courses, and what you're supposed to do to write a particular CCI exam. Which course should you go for to write a particular CCI exam? Everything, every detail I will discuss. I've also discussed in detail about the course and one of the technical topics, right? So now, anyone has any question regarding whatever we have whatever I have discussed in, or anyone would like to add anything, or anyone would like to ask anything, please feel free. All right. If no, let me move further. So, as I said, whatever we have seen over here, the diagram that I showed you, the one main component in all of these topology was a switch. Okay, was a switch. Okay, obviously we easily understood that all the devices are connected to a switch, and then this switch is sending the data to another switch, or probably directly connected to a router, it is sending the data towards the router, right? But one thing that we have to understand is that how is the switch getting a data from the devices that it is connected to, and once it gets the data, how is it sending the data to another device, or how is it forwarding the data to another device? Okay, that's what we're supposed to understand. So the switch, okay, understand, if I have to explain you in a very simple term, understand a switch like a person. Okay, understand the switch like a person. So imagine that some person, you are sitting, you're standing at the corner of a street, okay, just simply looking at the sky or just pondering over your thoughts, something. Okay, so one person comes to you, and let's say that he is coming from, for example, let's say he's coming from Delhi. Okay, he's coming from Delhi. So the person reaches out to you and he said, "Hi, I want to go to," let's say you are sitting in Jaipur. Okay. He asks you that, "Hi, I am coming from Delhi. I want to go to, let's say, Mumbai. Okay. Can you tell me? Can you point me out how to go to Mumbai?" Okay. So if you know, if you know how to go towards Mumbai, or if you know how to go to Bombay, right? You would direct him that, okay, use this road. Okay. Use this national highway to reach Bombay, or use this national highway to go to the next city. Probably that should be Ahmedabad, if I'm not wrong. Okay, that should be Ahmedabad, right? You reach Ahmedabad, and then you ask someone, he will guide you how to reach to Bombay, right? That is how basically a person's understanding is. And with that, let me also tell you, whatever devices, whatever protocols, whatever technologies we learn in networking is taken from real time examples. Okay. So, as I said, as a person, you should know how, until as you know how to reach Bombay, you will not be able to guide that person. So, Bombay for you is a destination, and Bombay for the person that is coming from here is also a destination, right? Similarly, a switch also forwards or directs a particular data towards the destination using some parameters. Okay, so if a data hits the switch, okay, and if it wants to go to a particular destination, the switch looks for that destination. Does it know about that destination? And then it makes the forwarding decision. And the destination in switching term or in networking term, if I have to call, is called as a MAC address. All right, is basically called as a MAC address. So a switch requires a MAC address. A MAC address is just like our address, our house address, which is unique in nature. My house address, whatever house address I have, obviously no other person, no other house in the world will have my house address. It's the same thing. Any networking device, first of all, every networking device has its own MAC address. Okay, so the MAC address is unique in itself. No other device in the world will have a duplicate MAC address. And if it has a duplicate MAC address, first thing, it's a manufacturing error. That's the first thing. There is no other error that you can find. It's a manufacturing error, and probably it, if ever it is in the network, it may create a lot of uh, 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 what do you say, traffic drops. I can say that. Now, how does a MAC address basically look like? Okay, so our house address has a house number, then a building number, then a street name, then the area name, then the city, then the pin code, then the state, etc. A lot of things, right? Similarly, a MAC address is is a 48 bit number. Okay, it's a 48 bit. When I say bit, we know that a bit is either a 1 or a 0, not and, sorry. It's either 1 or 0. So you have 48 bit of 48 bits which make up a MAC address. Okay, now out of these 48 bits, okay, and it is written in this format. Let me open up my Wireshark. Right. So yeah, this is how a MAC address basically look like. B8, B7, DB, 3C, 72, 38. Okay. Now this is a 48 bit, meaning that uh, each of this number that you see, they are hexadecimal form, meaning that one hexadecimal bit is of 4 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there are 12 digits, 12 into 4 bits. Each of these hexadecimal values are 4 bits long. So 12 into 4, 48, right? So each MAC address is 48 bits long, where when there is an organization, I forgot the full form of that organization. That organization is called as IOU. I forgot the full form of the organization, and also not important to remember. Okay, this organization is responsible for creating the MAC addresses, or not creating, or this organization is responsible for creating the rules and regulations and policies for how to create a MAC address. What they do is the first the first 6 digits, 1, 2, 3, 4, 5, 6. This first 6 digit of the MAC address, they are the one who assign it, and they assign it based on the organization. Let's say that it's a Cisco device. For example, let's say it's a Cisco device. So they say that every Cisco device, or let's say every Cisco switch, will have a MAC address starting with B8, B7, DB. That's all they decide. B8, B7, DB. They decide that every MAC address of a Cisco switch will start with these 6 digits. The rest of the 6 digits, 1, 2, 3, 4, 5, 6. It's up to Cisco to assign the value. It's up to Cisco, right? So what basically happens is any hardware network engineer or anyone who is working on the hardware level, when he sees this particular these 6 digits of the MAC address, he easily understands that it belongs to Cisco. Yeah, anyone saying something? Hello? Washing machine. I would request everyone to please mute yourself. All right. So, and as I said, this is given by IOU, and this is the last 6 digits, okay, is assigned by the company or the organization to which this particular 6 digits is assigned. Let's say this is assigned to Cisco. So Cisco decides the last 6 digits. Okay. There was an image that I saw on LinkedIn, right? Facebook. We all know Facebook. Okay. So Facebook, Facebook also has devices in its network. So Facebook was very clever. What it did, it made these digits, okay, these digits in its MAC address, right? You know how? I'm pretty sure it would have paid a hell lot of money to the IOE to make the MAC address look like that it belongs to Facebook. How? FACEB000C. This is how the Facebook's MAC address basically looks like. Obviously, you cannot have K, so that's why you use C. and then it used random numbers over here. That is how Facebook created its own MAC address. Okay, so and now if you imagine, why are these B8 etc.? These are hexadecimal forms. Okay, 4 digits long, 1, 2, 3, 4, right? So 0001. I hope everyone knows these hexadecimal form or the binary format, right? 0100, 0101, 0110, 0111, 1000, 1010, 1011, 1100, 1110, 1111. Okay. So as I said, each of those digits are 4 bits long, right? And we write them in hexadecimal form as this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? But in the hexadecimal form, this is the decimal form. This is decimal form, but in the hexadecimal form, we write 10 as A, B, C, D, E, and F. So Facebook over here cleverly used and cleverly paid IOU as well to create its unique MAC address, which would look like FACEBO B00C. So it used all those hexadecimal form and created its own MAC address, which obviously will obviously be unique in the entire world of MAC addresses, right? So that is how MAC addresses are created. Now, the second thing is using the MAC address, how is switch able to forward a data? That's what we are supposed to know now. Okay. But before I move, anyone has any question regarding the MAC addresses? No? All right. So our topic of the day, how does a switch work? How does a switch work? Right. Now, when I'm explaining this particular concept, there are few things that I'm assuming. Okay. There are few things that I am assuming. Assumption number one. Assumption number one is that all devices that are connected to the switch, devices that are connected to switch, know each other's MAC address. Know each other's MAC address. Okay. And when I'm discussing this particular example or whatever the concept that I'm going to explain, I will only be explaining from the MAC addresses point of view. No IP addresses are involved over here. Okay. So assumption number one, all devices that are connected to the switch know each other's MAC. That's assumption number one. Right. Second assumption is that the MAC address table. I'll explain what is this. MAC address table of the switch is empty. Okay, switch is empty. Now, what is a MAC address table? First, let me explain that. What is a MAC address? So let's go back to the same example where a person came to you, right, and he asked your direction to go to Bombay. He's coming from Delhi, and you are sitting in Jaipur, and he asked you how to go to Bombay. So when you directed him to Bombay, there were a couple of things that were running in your mind. Okay, that were running in your mind. First thing, the destination. Right. For you, the destination was he asked you how to reach Bombay. Right. So your brain started to run, or your brain started to make calculations based on Bombay. That was your destination, right? And then you started to think how should I direct him? Okay, which way should I send him? Which way should I send him so that he goes towards Bombay? So the other thing is you're trying to think how, which exit path should you send him out? Okay, that is probably in our example, that is the national highway. Which national highway should you tell him so that he reaches Bombay, right? So this is a kind of a mind map, or this is a kind of a table that was created in your head. With Bombay, which national highway should you choose? Or you will direct him like go straight, go left, etc. Whatever direction, right? That was going in your head. So a table is formed in your head. Similarly, a table is present inside a switch. A table is present inside a switch, and that table is basically called as a MAC address table. Okay, a MAC address table is created. So in this MAC address table, the switch, the switch has the list of destination MAC addresses, different destination MAC addresses, and how to forward them or how to send them out of which interface of the switch. Okay, so okay, before I jump to the next discussion, MAC address table is not same as ARC table. Is not same as ARC table. MAC address is different. ARC table is different. I'll discuss that by the end of the session. Okay. So no, the MAC address table and ARC table are not same. ARC has the uh, MAC table versus IP addresses. This is what the ARC table has. MAC address table does not have IP addresses. So this is these are different catalyst switches that we can see. Okay. So when I say the switch has as in the table that I mentioned, this switch has, what do you say, interfaces, destination MAC addresses, and the interface, right? So when I say the interface, basically I'm talking about these ports. Okay. Yeah, what I was asking is, before I move to the next discussion, is there anyone who is zero in networking over here? Anyone who has no idea of what networking is, or what switch is, or what everything is? Is there anyone over here? Because if there is anyone, I would slow down my pace. Okay, I would explain what is an interface, etc., so that that person understands. Okay, I'm not assuming that everyone knows everything, right? And please do not think that this is an advanced course, so that I won't be explaining the simple concepts. I would just skip those concepts. Do not assume that I would still explain those concepts. Just let me know if you are completely new to the networking and you have no idea what is this about. Just let me know. So based on that, I will slow down my pace. Based on that, my explanation would be that basic as well. Anyone here? No one. All right. So when I say the MAC address table will have majorly two columns, a destination column, destination MAC address column, and the other is the interface. So when I say interface, it is these interfaces that the switch will use to send the data out of. Okay. Now, first thing first, as I said, assumption number one, all devices that are connected to the switch know each other's MAC address. Second assumption, MAC address table, which basically looks like this of a switch, is empty. Okay, these two assumptions I am taking to explain how switches work and how switches forward data, how switches learn MAC address. All right. Now, this is a switch. PC number 1, PC number 2, PC number 3, PC number 4. All right. Now, the MAC addresses of each of these PCs are, just for understanding's sake, is 11111, meaning that all digits of the MAC address is 1. For switch PC number 2, all digits of MAC address is 2. All digits of PC number 3 is 3. All digits of MAC address of PC number 4 is 4. Okay. So again, I'm repeating the assumptions. We are assuming that all the PCs know each other's MAC addresses and the MAC address of the switch is empty. This is my assumption. So this is interface number 1, interface number 2, interface number 3, and interface number 4. All right. So let me draw the switches MAC address table as well. So this will be destination MAC address, and then this would be the exit interface. Not the exit interface. Let me write this as just an interface for now. Interface. Okay. Now, let's imagine that PC number 1 over here is sending a data to PC number 3. PC number 1 is sending a data to PC number 3. And as I said, I will be discussing only from a MAC address point of view, no IP addresses involved. All right. So when PC1 is sending a data to PC number 3, the source MAC address. The source MAC address is going to be 1111, that is PC number 1's MAC address, and the destination MAC is going to be of PC number 3, that is 3333. Not just 4 digits, as I said, all digits of the MAC addresses is 1 and 3. Right. Now, PC number 1 sends this data. Right. Now, the switch is receiving this data on interface number 1. So the first thing, how switches learn the MAC address. Switches learn the MAC address okay. Switches learn the MAC address by reading the incoming frames source MAC. Okay. So what I've written that switches learn MAC addresses by reading the incoming frames source MAC address. That's the first thing, first and foremost important thing. So when switch received this particular data from PC number 1, it read this frame and it says that, okay, I have received a frame who has a source MAC address of 1111 and it was received on my interface number 1. Okay, so first thing, switches learn MAC addresses by reading the incoming frames source MAC address. So it populated its MAC address table by reading 1111 as the source MAC address, and it was received on its interface number 1. Okay, then the second thing it does is it reads the destination MAC. Now, if the destination MAC address is not present in the MAC address table, listen to me very carefully, if the destination MAC is not present in the switch's MAC address table, switch is going to send it out of all the interface that it has connection to. The switch is going to send the data out of all the interfaces that it has connection to. So it sends the data to PC number 2, it's PC number 3, and PC number 4. The reason is it does not know the MAC address 3333 and it is not present in the MAC address table. Okay, so the next point, if the destination MAC is not present in the MAC table, the switch will broadcast it out of all the interfaces. All right. So that's the second point. If the destination MAC is not present in the MAC address table, the switch is going to broadcast it out of all the interfaces. Unlike us human being, right? If it's just the same thing. If some person, that Delhi guy, he came to me and he asked, "Do you know how to go to Bombay?" And if I do not know how to go to Bombay, I would say, "No, sorry, boss, I don't know." Okay. So because we are human, the other guy would probably move on to the next guy and he'll ask, "Do you know how to go to Bombay?" But over here, the switch does not know the destination map. And when it does not know where the destination map is connected to, okay, it will broadcast it out of all the interfaces. Now, what happens is that PC number 2 is going to drop this packet. PC number 4 is going to drop this packet because the destination MAC of 3333 does not belong to them. The only device that is going to accept this packet is PC number 3, 3333, which is the same MAC. So PC number 3 sees the incoming packet and it sees that, okay, this particular frame belongs to me because the destination MAC is 3333. All right. Now, for PC, now what PC number 3 is going to do, PC number 3 is now going to respond to this particular frame. Right? When PC3 responds, PC3 responds to PC number 1. The source MAC would be 3333 and the destination MAC will be 1111. Right? This is the frame that PC number 3 is going to send to PC number 1. Now, PC number 3 sends this data, switch receives it. So the first point that I mentioned over here, switches learn the MAC address by reading the incoming frame's source MAC address. So over here, the switch sees that, okay, I have received a frame which has a source MAC of 3333. So let me note that down. And it was received on my interface number 3. So it also notes the interface, right? So it populated its MAC address table using the source MAC. Then the second thing it checks is the destination MAC. But is the destination MAC present in its MAC address table? In this case, yes, the destination MAC is present in the MAC address table. It sees the destination MAC in its MAC address table. So it sees, yes, I know the destination MAC address. And to forward the data to this particular destination MAC address, which interface should I use? I should use interface number 1. And over here, instead of broadcasting the packet, the switch simply forwards it out of interface number 1 and the frame is received by PC number 1. All right. So when the switch does not know the destination MAC address, basically it's not present in the MAC address table, it will broadcast it to all the other PCs. Not PCs. It will broadcast it out of all the interfaces. But if the MAC address is present in the MAC address table, it will simply forward or send it out of that interface. Now I will stop here. Any question? Anyone? Please feel free to ask. Okay. Let's make this session a very interactive one.
Laksh, so this broadcast is ARP broadcast.
No, this is not ARP broadcast. ARP is also a broadcast, but this is not an ARP broadcast. This broadcast is because the destination MAC is not present in the MAC address table of this switch. So it's like if I say, understand the logic of the switch. Switch is looking to send the data out of a particular interface. Okay. It needs an interface to send the data out of.
Correct. Yeah.
But in this case, when earlier this particular MAC address, when this particular MAC address was not in the MAC address table, first it did not even know the MAC address. It did not even know the exit interface. So when it does not know the MAC address, and when it also does not know where the MAC address is residing, on which interface is it residing, it cannot just assume. When it cannot assume, it broadcasts. So that wherever this PC or wherever this MAC address is connected to, at least it will reach to that particular device. Whoever owns this MAC address, at least this particular frame would reach that device. With that like confidence, it broadcasts it out of all the interfaces.
Yeah, but there's no underlying protocol involved.
No. This is how the switch is designed. When the switch does not know where to forward, it will broadcast. That's how the switches are designed.
Okay. Thank you.
But in the next case, the switch knew exactly where to forward. Right. When the frame was coming from PC number 3, PC number 1, it made a note of the source MAC address, that is PC number 3's MAC address, and it was received on interface number 3. Right. Then it checked for the destination MAC address. The destination MAC address and the exit interface both are present in the MAC address table. So it exactly knows where the destination MAC is present. To out of which exit interface, if it forwards the data, it would reach that particular MAC address. And that is why in this case, it did not broadcast. It basically had a unicast. So it forward or it sent it out of interface number 1.
Okay.
Right. Anyone has any other question? No? All right. Now let's take another example. Again, same, let's say PC1 is trying to ping PC number 2. Okay, PC1 is trying to ping PC number 2. Right. So PC2's MAC address would be the destination MAC address. Right. Now PC1 sends this data to switch. Switch receives it. So please make sure, please understand that every time the switch receives a frame, a particular frame, it would check the source MAC address. Is the source MAC address present in its MAC address table or not? So here the switch received the MAC address. So not received the MAC, it received the frame. It checks the source MAC address. The source MAC address is present in the MAC address table. So that's okay. Then the second thing, it checks the destination MAC address. Over here again, the destination MAC address is not in the MAC address table. So again, the switch does not know where the MAC address, to which interface the MAC address is connected to. Right. So it cannot just assume any interface. So without any assumption or without any predefined thinking or prejudice, what it does is it just broadcasts this packet out of all the interfaces. It broadcasts it out of all the interfaces. Right. So over here again, PC3 is going to discard this packet. PC4 is going to discard this packet because the destination MAC does not belong to these two PCs. Okay. Now, PC2 receives this and PC2 is going to respond. So when PC2 responds, the MAC address, the source MAC address is of PC number 2. Okay, so this is the frame. Right. Now, PC2 responds. The switch receives it. So now the next thing the switch does is it reads the source MAC address. Does it know the source MAC address? No, it does not know the source MAC address. So it makes a note of it. And on which interface was it received? It was received on interface number 2. Right. The next, the destination MAC address. Does it know the destination MAC address of 1111? Yes, it knows the destination MAC address of 1111, and it also knows where this destination MAC is sitting, on which interface is this destination MAC address sitting on. Right. Sitting on meaning out of which interface should it send the data that it will reach this destination MAC address, that is interface number 1. So it forwards this data to PC number 1 out of interface number 1. So this is how the switches basically learn the MAC addresses and forward the data. If the switch knows the MAC address, it will directly send it out of that interface. But if the switch does not know the MAC address, destination MAC address, not source, the destination MAC address, if it does not know the destination MAC address, it is going to broadcast it out of all the interfaces. Clear? Any question? Anyone has any question? No. All right. Now, let me ask you guys one question. Now let's imagine that PC1 is trying to ping. PC1 is trying to ping PC number 4. Okay. PC number 4. Okay. Now, when it is trying to ping PC number 4, it will send the data. The switch receives it. Switch will read the source MAC address, right? The switch will read the source MAC address. It will see the source MAC address is present in its MAC address table. So fine. Then it checks for the destination MAC address. 444. 4444 is not present in the MAC address table. So obviously it is going to broadcast it. Okay. Now, my question is for you guys. I don't know if you ever thought of it. Why is the switch broadcasting it? Why is the switch broadcasting it out of interface number 2, interface number 3? Why is it broadcasting out of these two interfaces? Because in the MAC address table, it is clearly mentioned that this destination MAC address resides on interface number 3. This destination MAC address resides on interface number 2. Why is it broadcasting this particular data out of 2 and 3 as well? It could just simply, if it is that intelligent, it could just simply forward this data to PC number 4 out of interface number 4. But it does not do so. It will forward it out of all the other interfaces as well. I hope you understood the question. My question is, in this switches MAC address table, it is clearly mentioned that these two MAC addresses, 2222 and 3333, are connected to interface number 2 and interface number 3. So what's the point of sending this particular frame out of interface number 2 and interface number 3, which will be eventually ignored or dropped by these two PCs? I hope you got the question. Has everyone understood the question? Give a thumbs up, yes, no, something. Has everyone understood the question? Guys, just let's make it interactive. Okay, I think I'm not that boring, right? Okay, so I am assuming that everyone has understood the question. Okay, so the reason the switch will still forward the data out of these two interfaces, in spite the fact that it knows these interfaces are connected to only these two MAC addresses, even though it will still forward or broadcast this particular frame out of all the three interfaces. The reason is that the switch only knows that the MAC address, to reach this particular MAC address or to send the data to this particular MAC address, it is supposed to send the data out of interface number 3. That's all it knows. अगर सबको हिंदी आती है तो मैं इसको हिंदी में समझा दूं. स्विच को सिर्फ यही पता है कि ये जो डेस्टिनेशन मैक एड्रेस है वो उस डेस्टिनेशन मैक एड्रेस को रीच करने के लिए इंटरफेस नंबर 3 का यूज होना है. उसको सिर्फ यही पता है. दैट्स ऑल इट नोस. It does not know that this particular destination MAC address device, is it connected directly or is it connected through multiple other switches. उसको ये नहीं पता क्या ये मैक एड्रेस, ये जिसका भी मैक एड्रेस है, ये डेस्टिनेशन मैक एड्रेस जो भी डिवाइस का है, क्या वो उस स्विच से डायरेक्टली कनेक्टेड है या फिर ये डेस्टिनेशन मैक और इस स्विच के बीच में 10 स्विच भी हैं, ये स्विच को नहीं पता. And for that reason, and for that reason, it still broadcasts it out of all the interfaces. Is the question and is the answer clear? Is there anyone who did not understand this? Or is there anyone who understood this? Yes, no? Okay. So because this switch does not know, it only knows that to reach or to send the data to this particular destination MAC address, it needs to send the data out of interface number 3 or interface number 2. That's all it knows. It does not know if if the PC is if this PC is directly connected to the switch or if there are multiple switches in between these two. Okay, so that is why the switch does not make any assumption and it forwards the data out of all the interfaces. Okay, so obviously PC number 2 and PC number 3 are going to drop this packet because the destination MAC of 4444, it does not belong to them. It only belongs to PC number 4. Now PC number 4 is going to respond. When PC number 4 responds, the source MAC is going to be 4444. Destination MAC is going to be 1111. Okay. Now PC4 response. Switch makes a note of it, which reads the source MAC address 4444, and it was received on interface number 4. Then it reads the destination MAC address. Is the destination MAC address known to the switch? Yes, it is known to the switch. And how to send the data towards this destination MAC address? That is interface number 1. So the switch forwards the data out of interface number 1 to PC number 1. All right. Anyone has any question of how the switch basically learns the MAC address and how the switch basically forwards the data using the MAC address? Any question? Anyone? No? All right. So now, if I have to expand this particular scenario using multiple switches, okay, now using multiple switches, it will be even clearer for you as to how the switches are forwarding data if there are more than one switches involved. Okay, and with that, you will be able to understand my previous question as to even though the MAC addresses are present on the switch's MAC address table, why is it forwarding the data? That particular answer would be even clearer when I explain you this concept using two switches. All right. So there is switch number 1, and you have the second switch, switch number 2. Okay. So multiple PCs are connected. One, two, three, 4, 5, 6. Okay, and these interfaces are interface number 1, interface number 2, interface number 3, interface number 4, interface number 5, interface number 6. Let me give this an interface number 7, and this is interface number 8. Okay, and this is the MAC address table for switch number 1. interface, and this is the MAC address table for switch number 2. All right. Now, again, the same assumptions that we made. The assumption number 1 was all the devices that are connected to the switches know each other's MAC addresses. Second assumption is the MAC address table of the switches are empty. These are the two assumptions that we are taking to understand this particular concept. Okay. So the MAC addresses of each PCs are 1111, 2222, 3333, etc. All right. 3333. This is 4444, 5555, 6666. Okay. So these are the MAC addresses of each PCs. Now, let's assume that PC number 2 is sending a data to PC number 4. Okay. So your source MAC is going to be 1111. Destination MAC is 4444. This is the frame which is sent by PC number 2 to PC number 4. All right. Now PC number 2 sends the data. The switch number 1 receives it. And as per the switching logic, we know the switch will read the source MAC address first. So the switch reads the source MAC address. It sees that it does not know the source MAC address. So it makes a note of it. And on which interface was it received? Sorry, PC2's MAC address is 222. So it makes a note of it 2222, right? And it was received on interface number 2. It made a note of it. Then next thing, it reads the destination MAC address. Does it know the destination MAC address? No, it does not know the destination MAC address. And when the switch does not know the destination MAC address, it will broadcast it out of all the interfaces. So over here, PC number 2, sorry, PC number 1, PC number 3 are going to drop the packet. Switch number 1 forwards this data out of the interface. Okay, this data is then received by switch number 2. So on switch number 2, it reads the source MAC address. It sees that 2222. Does it know the source MAC address already? No, it does not know the source MAC address, and it was received on interface number 8. Okay, does it know the destination MAC address? No, switch number 2 also does not know the destination MAC address, and hence it will broadcast it. Okay, so over here again, PC number 5 and PC number 6 will drop the packet because the MAC addresses do not belong. The MAC address of 4444 does not belong to these two PCs, right? Any question? Anyone till here? This process? No questions? All right. So now PC number 4 is going to respond, right? When PC4 responds to PC number 2, the source MAC is going to be 4444 and the destination MAC is 2222. Okay, now PC number 4 sends the data. Switch 2 receives it. It checks the source MAC address. Is the source MAC address already present on the MAC address table? No. So it will make a note of it. And on which interface was it received? It was received on interface number 4, right? Then it reads the destination MAC address. Does the switch know the destination MAC address? Yes, it knows the destination MAC address. And how to forward the data? Out of the exit interface. That is 8. Give me a minute. Guys, let's take a break of 15 minutes, or let's take a break of half an hour. Okay, it's 11:30 now. Let's come back at 12. Okay, so let's come back at 12, and I will continue this session. Okay, so this is where I stopped. I stopped where Okay, so PC4 is replying back to PC2. PC4 replies, switch 2 receives it, right? Switch 2 makes a note of the source MAC address, right? That is 444. 4444 is received on the interface number 4. It made a note of it. Then it checked for the destination MAC address, that is 2222. Is it present in its MAC address table? Yes, it is present in its MAC address table. And to reach this 2222 MAC address, it should forward it out of interface number 8. Right. So it forwards it out of interface number 8. It reaches switch number 1. Switch number 1 reads the source MAC address 4444. Since it is not present in its MAC address table, it makes a note of it and it was received on interface number 7. Right. Then it reads the destination MAC address 2222. It knows the destination MAC address 2222 and it is supposed to be sent out of interface number 2. So it sends it out of interface number 2 and PC2 receives it. Okay. So the question that I had asked before explaining this particular scenario was, what was the need of switch over here to to forward it out of interface number 2 and interface number 3 when it already knows that interface number 2 and interface number 3 have these two MAC addresses? That particular question is answered over here. So you can see that PC number 4. PC number 4 is not directly connected over here. It is connected to another switch. Okay. So that is why the switch does not assume that the destination MAC address may be connected to it directly. Because it does not make this assumption, that is why it broadcasts it out of all the interfaces. I'll give you another example. On switch number 8, like for switch number 2, to reach any of these MAC addresses 2222, 1111, 3333, it will enter 1111, 1111, 2222, 3333. It will use interface number 8 only to reach switch number 1, because this is the only exit interface it has to reach other interfaces, sorry, other MAC addresses, which are not directly connected to interface number 8, which are connected to switch number 1. So multiple MAC addresses can be reached via interface number 8, or can be reached out of one single interface. Similarly, for switch number 1, if it needs to reach 5555, PC number 5 and PC number 6, it will use interface number 7 to send the data. Right? Obviously, these PCs need to first send the data to switch number 1, and PCs or PC number 2, 1 and 3, they need to send the data to switch number 2 in order for these two switches to learn their MAC addresses. But once they learn their MAC addresses, they only have one single interface to reach other MAC addresses or different MAC addresses. Or if I have to tell you about this, okay, obviously from Delhi to, let's say, Bhopal, okay, the capital city of Madhya Pradesh. Okay, you can reach Bhopal in many different ways. Okay, it's just not one, it's just not one single path. Okay, there are different paths. Let me just open Google up and check how many paths do we have. All right. So if you see from Delhi to Bhopal, there are two ways. However, from Delhi to Bhopal, there is one exit interface, and out of that same exit interface, it is going through multiple cities. It is going to Alwar, it is going to Kota. Then, if I zoom in here, It is going to Rajgarh. There are like and the other path that going to Guna. It's going to Shivpuri, Gwalior, Agra, to Agra. So one exit interface can lead you to different destinations. Okay, so you can see Delhi is this exit interface, this whatever this national highway is not directly connected to Bhopal. It goes through different cities, right? So if Delhi switch just assumes that Bhopal's MAC address is directly connected to it, okay, and it stops broadcasting, that will be a problem. That's the same reason why switches broadcast their unknown destination MAC addresses to every interface, even they know that there are other MAC addresses sitting on that interface. Did everyone get this point? Yes, no, anyone? No. Okay. So Nitin says no. Uh, Nitin, shall I explain it in Hindi if that's okay for you? ओके सो मेरा कहने का मतलब ये है कि मैंने ये जो एक्सप्लेनेशन दिया था, ठीक है, मैंने जो क्वेश्चन यहाँ पे पुट किया था, मैंने ये पुट किया था कि अगर पीसी नंबर वन, अगर पीसी नॉट नॉट हाँ सॉरी, यहाँ पे पीसी नंबर वन अगर पीसी नंबर फोर को पिंग करता है, ठीक है, स्विच को पहले से ही ये तीन मैक एड्रेसेस के बारे में पता है और उसको ये भी पता है कि ये तीन मैक एड्रेसेस इन इंटरफेसेस पे कनेक्टेड हैं। अगर पीसी नंबर वन स्विच को फॉरवर्ड करता है, स्विच क्या करेगा, क्योंकि उसको डेस्टिनेशन मैक एड्रेस के बारे में नहीं पता है, तो वो ये डेटा को सभी इंटरफेसेस से फॉरवर्ड कर देगा। ठीक है, मेरा क्वेश्चन ये था कि स्विच ये क्यों फॉरवर्ड कर रहा है, स्विच ये क्यों फॉरवर्ड कर रहा है, ये इंटरफेस नंबर टू और इंटरफेस नंबर थ्री को भी क्यों फॉरवर्ड कर रहा है, जब उसके मैक एड्रेस टेबल में क्लियरली मेंशन्ड है कि भाई ये दो इंटरफेसेस पे सिर्फ ये दो मैक एड्रेसेस ही बैठे हैं, इन दोनों इंटरफेसेस पे वो क्यों फॉरवर्ड कर रहा है? वो सीधे सीधे इंटरफेस नंबर फोर से डेटा फॉरवर्ड कर सकता था, बट उसने नहीं किया। मेरा क्वेश्चन ये था, वो क्यों टू और थ्री से भी ये जानते हुए कि भाई इन दोनों इंटरफेसेस पे ये दो मैक एड्रेसेस बैठे हैं, उन पे क्यों फॉरवर्ड, इसलिए फॉरवर्ड कर रहा है क्योंकि सिनेरियो ऐसा भी कुछ हो सकता है कि ये जो पीसी नंबर थ्री है, ये जो पीसी नंबर थ्री है, जरूरी नहीं है कि वो यहां बैठा है, वो हो सकता है यहां बैठा हो। पीसी नंबर थ्री हो सकता है वो यहां बैठा है, ठीक है, और ये है पीसी नंबर फाइव। तो तो जो ब्रॉडकास्ट करेगा वो पीसी नंबर थ्री, यहां देख सकते हो वो स्विच से यहां पे डायरेक्टली कनेक्टेड नहीं है, वो दूसरे स्विच से कनेक्टेड है। उसको इस स्विच को सिर्फ ये पता है, उस स्विच को सिर्फ ये पता है कि भाई ये मैक एड्रेस को मुझे रीच करना है तो मुझे ये वाला एग्जिट इंटरफेस यूज करना पड़ेगा। सिमिलरली मैंने गूगल मैप का वही एग्जांपल दिया, दिल्ली से अगर मुझे भोपाल जाना है, दिल्ली से अगर मुझे भोपाल जाना है तो मैं बहुत सारे स्विचेस या फिर बहुत सारे सिटीज से होते हुए जा रहा हूँ, तो एक ही इंटरफेस में बहुत सारे सिटीज को क्रॉस करते हुए जा रहा हूँ। तो अगर दिल्ली के एग्जिट इंटरफेस पे, ठीक है, दिल्ली ने बोला कि भाई मेरे एग्जिट इंटरफेस पे सिर्फ भोपाल ही कनेक्टेड है, वो तो गलत सोच है ना उसकी। उसके ये वाले इंटरफेस पे जो भी नेशनल हाईवे है, उससे बहुत सारे अदर सिटीज कनेक्टेड है, जिस सिटी से कनेक्ट होते होते हुए वो भोपाल पहुंच रहा है। सिमिलरली यहाँ पे भी है। अगर स्विच ने ये सोच लिया कि भाई मेरे ये दोनों एग्जिट इंटरफेस पे सिर्फ ये दो मैक एड्रेसेस बैठे हैं, तो उसकी गलत सोच है, तो वो उसकी गलत सोच है, इसी वजह से वो ब्रॉडकास्ट करता है। ये हो सकता था कि भाई ये स्विच थ्री यहाँ पे, ऐसा नहीं है, यहाँ पे एक और स्विच कनेक्टेड है जिससे पीसी थ्री कनेक्टेड है, जिससे बहुत सारे अदर स्विचेस भी कनेक्टेड, अदर पीसीज भी कनेक्टेड है। तो अगर स्विच ने ये सोच लिया कि भाई मेरे इंटरफेस नंबर थ्री पे, ठीक है, सिर्फ यही दो मैक एड्रेसेस कनेक्टेड है, वो तो गलत सोच है, क्योंकि इस वाले इंटरफेस से वो ये वाले पीसी को भी रीच कर सकता है, ये वाले पीसी को भी रीच कर सकता है और पीसी नंबर थ्री को भी रीच कर सकता है। इसी वजह से स्विच अगर अननोन अननोन नहीं, हाँ, अननोन मैक एड्रेस अगर उसको रिसीव होता है तो वो ब्रॉडकास्ट करता है. एनीवन हैज एनी क्वेश्चन अबाउट इट? That's what I have written here. If the destination MAC is not present in the MAC address table, the switch will broadcast it out of all the interfaces. Right? Anyone has any other question regarding this? Okay. So this is how the switch will forward the data. So let me open up Cisco Packet Tracer and we'll just do a small practical for it. All right. So this is Cisco Packet Tracer tool. I have already installed it on my PC. Okay. All you need to do is just simply search for Cisco Packet Tracer download. Probably you will find yeah, you'll find such a community and this one as well. Click on this particular link. Okay, when you do a Cisco Packet Tracer download, click on this first link. Like on my browser, it shows the first link. Probably on your browser, it may not show the first link. Probably it may be second or third link. Check for this particular link. Open it. Okay. Once you open it, there is a community discussion that's happening, and it will have a hyperlink to the Cisco Packet Tracers download page. So once you open it, you need to create an account for this. It's free of cost. Okay, it's free of cost. And once you create an account for it, you need to start this course. Okay, you need to start this course in order to learn the Cisco Packet Tracer. Okay, so let me log in. Hmm. Okay, anyway, some problem. Okay, so once you log in, okay, once you log in and create an account, okay, you need to start this particular course. And once you start this particular course, right, you will have this module how to install a packet tracer. Okay, and you will have a download link as well. Okay, download it and you can start using this Cisco packet tracer too. Right. I'm sorry I could not show you because some authentication error was there. All right. So once you download and install the packet tracer, it would probably look like this. Not probably, it will look exactly like this. So in Cisco Packet Tracer, there are two workspace. On the bottom right corner, you can see a real-time workspace, and then there is a simulation workspace. So I'll explain you as we go on what these two workspaces do. Right. Below this workspace, you have an option of choosing the devices that you would like to add to this particular workspace, right? So you have networking devices. If you click on networking devices, you can see routers, switches, hubs, wireless devices, security devices, cloud devices, etc. All that. And then if you click on end devices, you can see PCs, laptops, servers, etc. So what I will do is I will explain the concept that we just saw today, right now, using this Cisco Packet Tracer. So let me explain you the first concept using one single PC. All right. So I will use multiple PCs over here, PC1, PC2, PC3, and I will use a switch. Okay. Switch number one. Okay, so this is how I have connected, and let me give the same assumption that all the PCs know about each other's MAC addresses. That was assumption number one. Second assumption is switch's MAC address table is empty, right? These were the two assumptions that I made. So just let's just wait for these links to come up, all right? And then what I will do is I will make I will assign IP addresses to these PC 10.0.0.1, okay, and PC number 2 will have an IP address of 10.0.0.2. PC3 will have an IP address of 10.0.0.3. PC2 also had 10.2, 3, and PC4 will have an IP address of 10.0.0.4. All right. So these are the IP addresses of these PCs. And to the first assumption is all the PCs know about each other's MAC address. So if I want all the PCs to know about each other's MAC address, I will have to ping them first. So ping 10 from PC number 1, I'm pinging PC number 2. Okay. I will ping PC number 3 as well. So people who understand this concept, let me tell you why I'm pinging. If I ping, all the PCs will generate ARP request, and with the ARP request, all the PCs will know about each other's IP addresses and MAC addresses as well. So the first assumption of all the PCs knowing about each other's MAC addresses is because I'm trying to ping each PCs over here. 10.0.0.4. All right. Then I will ping PC number 2 to different PCs, ping 10, 10.0.0.3, and ping 10.0.0.4. Right? Then PC number 3 and PC number 4 are all that is left. Ping 10.0.0.4. Now that every PC know about each other's MAC address, let me ping PC4 and PC2 as well. Ping 10.0.0.2. They know about each other's MAC address now. Okay, so but because I pinged, what happened is let me increase the font. Can everyone see the font of the CLI? Is it visible, or should I increase the font? Is it visible? Yes, no?
Yes, yes, Lance.
Yeah, okay. Can we do practice on Peanut Lab or EVNG? Yes, you can practice, but I do not have a Peanut Lab or an EVNG setup, because then to set up an EVNG lab, I need to get an access to a server, rent it up from somewhere. That's why I'm using a Cisco Packet Tracer and a GNS3 tool, because it will create independency to both of us. You do not have to depend on me for server access. I do not have to depend on someone for a server access, etc. And there are a lot of problems with EVNG, right? Sometimes the server is down, etc. All that thing happens, right? So with Cisco Packet Tracer, which has its own emulation, with GNS3, which has its own emulation, we can still understand the concept. Okay, trust me, I used these two softwares only to understand CCI concept, and I cleared the exam last year. So yeah, these two are enough. So, but because, as I said, because I pinged the PCs, the MAC address table of the switch will not be empty, right? So what I'm going to do is I will clear the MAC address table. MAC address table so that, okay, our assumption of the second assumption that the MAC address table of the switch is empty. So the first assumption, all the PCs know about each other's MAC address. Second assumption that the switch's MAC address table is empty. All these two assumptions are now true for this topology. All right. Now, let's try to ping PC number 1 to PC number 3. Let's check PC number 1's MAC address. The MAC address of PC number 1 ends at 3095. That would be the source MAC address when I try to ping. Okay. And the destination MAC address of PC number 3 would be E94D. Okay. So let me ping PC number 1 to PC number 3. I am on the simulation workspace. In the simulation workspace, if I do any kind of work, any kind of configuration, it immediately shows me what kind of data is generated by a particular device and how is it being sent to across all the devices in the network, right? So on PC number 1, let me do a ping to ping 10.0.0.3. All right. Now you can see that PC number 1 has generated a ping packet. In the ping packet, there will be IPv4 as well, IPv4 and layer 2 information as well. But we will concentrate only on layer 2 and that also MAC addresses. So over here, you can see E94D is the destination MAC address and the source MAC address is 3095. That is PC1's MAC address, right? Now, PC1 sends this data. Switch number 1 receives it. Interfaces to animation, show device, show device, labels. So yeah, so this what happened. Let me clear this again. Clear MAC address. Okay, and from PC number 1, let me ping again. Okay, so PC1 generated a packet. We can see the source MAC addresses, destination MAC addresses. Now, this is sent to the switch. Now, as I said, when the switch receives the data, it will read the source MAC address on the packet. Why is it so? Okay, it will read the source MAC address on the packet. So for this switch, what is source MAC address? 3095. And this 3095 was received on interface number 0/pass Ethernet 0/1 of the switch. So let's check the source MAC, the MAC address table of the switch. Show MAC address, and you can see 3095 is received on 0/1. So my first point that the switches learn the MAC addresses by reading the source MAC address in the incoming frame. That holds true. Okay, now then it reads the destination MAC address. What's the destination MAC address? The destination MAC address is E94D. Is E94D present in the MAC address table of the switch? No. When the MAC address table is not present in the MAC address is not present in the MAC address table, the switch will basically broadcast it. So now you can see it has sent it to all the PCs, not all the PCs, it has sent it out of all the interfaces that it has connection to. PC number 2, PC number 3, and PC number 4. PC number 2 and PC number 4 have dropped the packet because that is not their destination MAC address. It belongs to PC number 3, and you can see PC number 3 has accepted the data. Right now, let me open this packet. For PC number 3, the inbound detail, you can see the destination MAC is E94D, the source MAC is 3095. So PC number 3 understands that this particular data is for PC number 3 and it needs to respond. So let us open the outbound packet for PC number 3. When it opens the when we open the outbound packet, we can see PC number 3's MAC address is the source MAC. The destination MAC is PC number 1's MAC address. Right now, PC number 3 responds. When PC number 3 responds, switch will read the source MAC address, that is of PC number 3, and it makes a note of it. PC number 3's source MAC address was received on 0/3 of the switch. So let's open up the MAC address table. So it made a note of it. E94D is the source MAC address of PC number 3, which was received on 0/3. Then it checks the destination MAC address. Destination MAC address, does it know the destination MAC address 3095? Yes, it knows the destination MAC address. And out of which interface should it send the data? That is 0/1. So now switch number 1 forwards the data out of interface 0/1 alone because it knows the destination MAC address. Any problem understanding this flow? Anyone? Or anyone has any questions about this? Or anyone would like to add anything over here? All right, thanks, Amit. Anyone else? Okay. Now, if I try to ping PC number 2 and PC number 4, we would see the same thing. Ping 10.0.0.4, I'm on PC number 2. Okay, so you can see PC number 2 generated a packet, okay, with a source MAC of its own 49D0 and destination MAC of 3AA0. This is PC number 4's MAC address. This is PC number 2's MAC address. The PC forwards this data, switch receives the data on 0/2, makes an entry of the source MAC address. 0/2, it made an entry. Okay, it made an entry for 49D0, that is PC2's MAC address on 0/2. It does not know the MAC address or the destination MAC address of PC number 4. PC number 4's MAC address is not present in the MAC address table, and hence the switch is going to broadcast it. So it sends to PC number 1, PC number 3, PC number 4. PC number 1 and PC number 3 ignores them because that's not their MAC address. PC number 4 accepts it. So in the inbound detail, we can see 3AA0 is PC number 4's MAC address, and hence PC number 4 accepts it. In the outbound side, yeah, anyone saying anything? Hello? Siddheshwar, you want to say something? Hello? No? All right. So in the outbound side, we can see that 49D0 is the MAC address for PC number 2. 3AA0 is the source MAC of PC number 4. All right. PC number 4 sends this data. Switch then makes an entry for it. We can see 3AA0 is now has an entry on interface number 04. Does switch know about the destination MAC address 49D0? Yes, it knows, and where to send the data out of which interface 0/2. So now instead of broadcasting, it will send it directly to PC number 2, and PC number 2 can now directly talk to PC number 4. Okay. Now with this, what happened? The switch now knows every PC's MAC address. Switch now knows every PC's MAC address. So even if I try to ping PC number 1 and PC number 2, the switch will not broadcast. Ping 10.0.0.2. Okay. Switch receives the data. Switch already knows PC1's MAC address and the interface number. The switch then checks the destination MAC address. The destination MAC address is 49D0. That is PC number 2's MAC address, 49D0. Does the switch know about 49D0? Yes, 49D0 is present in the MAC address table. And out of which interface should it send? 0/2. So this time, instead of broadcasting, it will send it directly out of 0/2 and it would be received by PC number 2. All right. So the point where the switch learns the MAC address through source MAC, and if it does not know the destination MAC address, it will forward it out of all the interfaces. We saw that through the practical. All right. Now, let me do the other practical where we have multiple PCs involved. Okay, multiple PCs and multiple switches involved. Okay, so let me bring up another switch over here and add multiple PCs. PC number 5, PC number 6, and PC number 7. PC5 will have an IP address of 10.0.0.5. PC6 10.0.0.6. PC7 10.0.0.7. Now, again, the same assumption that all the PCs know about each other's MAC addresses should be true, right? So let me ping, let me delete few PCs so that it is easier for pinging. Right? PC number 2 here, PC number 5 here. All I need to do is just ping PC number 1 and PC number 5. Ping 10.0.0.5, receiving the reply, and ping 06 as well. Right? And PC number 2 as well. Ping 10.0.0.5 and 06. Okay. However, I will have to clear the MAC addresses of the switches. Show MAC address table. You can see here MAC address table. No entry. And on switch number 2 as well. Enable show MAC. So I will clear the MAC address table. Okay. Okay. So this MAC address that you see is the MAC address of the switch that it is connected to. That is switch number 1. Okay. Because the CDP protocol must be running between the switches, right? So that is why the two switches know each other's MAC addresses, not the PC's MAC address. So let me ping PC number 1 and PC number 6. All right. Ping 10.0.0.6. So our assumption number 1, where each PCs know about the MAC addresses of each other, that's one assumption, which is now true. Second assumption, the switches do not know about the MAC addresses of these PCs. Their MAC address table is empty. These two assumptions now hold true. So PC number 1 now tries to ping PC number 6. PC number 1 sends the data to switch number 1. Switch number 1 reads the source MAC address, and the source MAC address is 3095. Sorry, yeah, source MAC address is 3095, and it was received on interface 0/1. Let's check. Okay, 3095, it was received on 0/1, and the outgoing MAC address, sorry, the destination MAC address of 4BE5. 4BE5 MAC address is not known to the switch. So the switch will broadcast it out of all the interfaces. Okay, PC number 2 ignores it, but switch 2 receives it. Switch 2 receives the source MAC address of this frame on 0/1, and switch number 2 will make an entry for it. Okay, 3095 entered on 0/1. The destination MAC address is not known to the PC, not known to the switch. I'm sorry. The switch will broadcast. PC5 will ignore it. PC6 will accept it. All right. Now, when PC6 accepts it, and PC6 now need to respond. When PC2 needs to respond, this is the destination MAC address. This is the source MAC address, 3095. PC6 responds. Switch will make an entry for the source MAC address because the source MAC address is not known to the PC, so it will make an entry for it. Okay. 0/3, 4BE5 is the source MAC address of PC number 6. It made an entry for it. The destination MAC address, 3095, is known to the switch. And to send the data to this particular MAC address, it needs to send the data out of 0/1. And instead of broadcasting now, the switch will directly forward it out of 0/1. Switch 1 receives the data on 0/3 with the source MAC address. So now 4BE5, the source MAC address of PC number 6, is now having an entry with an interface number of 0/3. The destination MAC address, 3095, the switch already knows it. And to forward the data to this particular destination MAC address, it needs to forward the data to out of 0/1. So now instead of broadcasting, it will forward it to PC number 1. All right. Any question, any thing or any doubts do you have for this? After what time MAC address tables in switch is updated or expire? It will expire in 5 minutes or 300 seconds. Okay, so after 300 seconds, this particular MAC address table should be updated. But even if it is not updated, it's okay. Okay, let's say that all the PCs are not sending any data for 5 minutes. So what will happen? The MAC address table of the switch will be flushed, or it will be completely empty once again. And unless the PCs send any data, the MAC addresses of the switch will not be updated, because we know the MAC address table is only updated when the switch receives a data. So until and unless switch receives the data, the MAC address table of the switch will still remain empty. So to answer your question, 5 minutes or 300 seconds is the time. Okay. Any other question? Anyone else? Can you show the packet capture when the switch broadcasts? Okay, I think let me send it for PC number 2, from PC number 2 to PC number 5. Ping 10.0.0.5. I think it should be broadcast if I'm not wrong. Okay, the switch. Okay, see the packet capture. Inbound detail, the source MAC address is 49D0. The destination MAC is CDA1. So if your confusion is in the broadcast, the destination MAC should be broadcast. No. Switch this. Okay, first of all, please understand, switch is not creating the packet. The packet is created by the PC. Okay, the data is created by the PC, not the switch. That is why the MAC addresses do not have a broadcast. First. Second thing, this destination MAC address, CDA1, it should not be present in the MAC address table for the switch to broadcast. CDA1, is it present in the MAC address table of the switch? CDA1, do you see it anywhere on the switch number 1's MAC address table? No, it is not present. Because it is not present, now this switch will broadcast it. See, it sent it to PC number 1, it sent it to switch number 2 as well. Now, switch number 2 will make an entry for it. 49D0. Okay, that's the source packet, 49D0. 49D0 was received on 0/1. 49D0 is received on 0/1. The destination MAC address. What's the destination MAC address? CDA1. Is CDA1 present in the MAC address table of switch number 2? Nowhere. Because it's an unknown MAC address, it needs to broadcast it. So it will broadcast it to PC number 6 and PC number 5. Not PC number 5 and PC number 6, it will broadcast it out of 0/3 and 0/2. Again, the switches only broadcast it out of the interface. They do not know if the destination MAC addresses are they connected directly to it or not. They do not know. They are just doing their job of forwarding them out of all the interfaces. PC number 6 ignores it. PC number 5 will now accept it. Okay. So PC number 5 sees CDA1 is its own MAC address, right? Now PC number 5 will respond. In the outbound side, we can see this is now PC number 2, which is PC number 2's, sorry, PC number 5's MAC address, and this is PC number 2's MAC. Now PC responds. Switch number 2 accepts it, and it will make an entry for the source MAC. Sorry, I forgot the source. CDA1. Okay, so it made an entry for CDA1. CDA1 is now on 0/2. Okay, what was the MAC address for 6403 if I'm not? 49D0. 49D0 is the MAC address of PC number 2. 49D0, it knows how to forward the data. That is 0/1. Out of 0/1, because 49D0 MAC address was received on 0/1, I have to forward the packet out of the same interface. That's what the switch is thinking. So the switch now, instead of broadcasting, it will forward it out of 0/1 alone. And switch number 1 also knows the MAC address of PC number 2. It will forward the data to out of 0/2 alone. Clear? Any question? Anyone? Any question? No? Okay. Now, this is how the switches are basically sending and receiving the data. Okay. Now, moving on with our discussion. Okay. So, okay. So what I will do is I will stop my today's demo session over here. Okay. I will stop my demo session over here. But before I stop my demo session, anyone has any question? Because after I stop the demo session, I will also stop the recording and I will explain what I explained in yesterday's demo session about the Cisco certifications and about the course detail. I would be explaining that because that yesterday's session is already recorded. I'm not going to record the same thing in today's session. So I will stop today's session. But before I stop today's session, anyone has any question regarding this particular topic that we are discussing? No one? All right. So let me stop today's recording.